All right, so one important thing to know is that our equilibrium is kind of the endpoint of our reaction. And since it's the endpoint, our reaction is always going to go towards equilibrium, right? When you first start off the reaction, you probably have mostly reactants that are going to turn into products, but it's always going to go towards equilibrium, right? So here it's showing you these concentration stuff. Right here is equilibrium achieved, right? So before this, we're talking about Q. And then over time, Q will become K because you will go towards equilibrium. And so it's very important to know that Q will always go towards K. And Q and K are the same thing. They're products over reactants taken to the power of their coefficients. It's just that Q you're talking about before equilibrium, K is at or after equilibrium. So your reaction will always go towards equilibrium. So for example, let's take a look at kind of A going towards B in equilibrium. Concentration over here, time down here. We'll label A as this yellow, B as purple. So originally we'll say that there's a lot of A, and then it's going to decrease and then reach, stay constant. B is going to increase and then stay constant. Right, at some point, you have equilibrium reached. Before this is Q. After this is K. And when you reach time T, right, when equilibrium is established, your Q is going to equal your K. Generally, at the beginning of a reaction, at T equals 0, you have no products. It's not always true, but most of the time it's true. You have all the reactants. Right? Generally, you wouldn't start off by throwing products in your reaction mixture, right? You're turning something into something else, right? So anyways, Q is still just products over to the exponents over reactants to their exponents, right? Where the exponents are the coefficients, right? So originally, we have no products, so that means that this is originally 0 over the concentrations of the reactants to whatever value, and 0 over any number is 0. So in general, your Q starts at 0 and then grows towards K, but this isn't always true. We'll see examples of when maybe we're going in the opposite direction, or we start off with some reactants in the beginning. Another thing to note is that the values of K vary dramatically or drastically. It's a better word. So they can either be gigantic numbers, intermediate numbers, or very, very tiny numbers. But remember, the K is a representation of products over reactants. If you have a big K, that means that you have a big numerator, right? The big top number, and that's the products, right? So we say when K is over 1,000 or 10 to the third, it's mostly products. When K is equal to somewhere between 1,000 and 1/1000th, we say that it's a mixture of products and reactants. And when K is very small, so less than 1,000th, that means that we have mostly reactants. Remember, 1,000th can be written as 10 to the negative third, right? So K can be big numbers, it can be little numbers, but remember, it's just the ratio of products over reactants. Big K means your reaction is going to give you mostly products. Little k means that your reaction is mostly going to stay at your reactants. One thing to note here is that we are no longer talking about kinetics. We are now talking about equilibrium and eventually thermodynamics. So this K value says nothing about how fast a reaction is. It just tells us where you're going to get to at the end point. So this reaction might take 1 second, or it could take 1,000,000 years. equilibrium, and the study of this K will not tell you that. To figure out this stuff, you have to study kinetics. So we'll see an example of K coming up.